What I'd like to do now is to access a RESTful web service. This is a very common thing to do, of course, in an application. Even if it isn't necessarily RESTful, we often need to communicate with the server side. And, of course, HTTP is available right there. Android devices are, even though they've gotten extremely powerful over the years, they are limited memory, limited processing power, limited disk space devices in general, so that if you want to keep a lot of data available or to process it in any significant way, it's often good to do that on the so-called server side and communicate back and forth with that when necessary. In this case, I want to access a RESTful web service that it's RESTful in name only, really. It only supports GET requests. It retrieves data. I can grab data, but I can't post, put, or delete anything. I can't update the service while I'm there or do anything like that. Now, in order to access a URL inside of an Android application, you may notice that inside the API, there are a series of packages called org.apache.http. This is a wrapper, or basically an example, of the Apache HTTP client project. It was interesting that very early on in Android's life cycle, they decided to add a version of Apache HTTP client to the Android OS, to the API. The thing is, though, is that over the years, this has become less and less popular, and one of the announcements at Google I/O in 2015 was that they're basically going to be phasing it out. So while they really don't want you to use it now, once they move to the M version of Android, it's likely going to be removed entirely. So it's interesting to see that it's there. I wouldn't spend any time on it. I wouldn't worry about it. Now, if it turns out you really like the Apache HTTP client project, if you really like using that for accessing HTTP resources, there's no reason you can't actually find the dependency for HTTP client now, the current version of it, and simply paste it into your Gradle build as a dependency. Those classes will be downloaded and added as any other normal Java library would be added, and you can still use that. That's not a problem. They just don't want you to use the one that's bundled into the Android API at the moment because it's potentially going to be removed, probably going to be removed. So what do people do instead? Well, there are some basic classes inside of Java, but they're very awkward to use. One of the relatively popular clients is something called OKHTTP. I have the web page here. You'll notice that this is from a site called Square, and this is their GitHub I/O page. The company called Square is very active in the Android marketplace, and they provide a rather wide range of useful libraries. This is one of them. So even as they say here, this is an HTTP client that works with HTTP2 and Speedy. It does connection pooling, it has caching and gzip and all that kind of stuff. And they say it's very nice for Android versions 2.3 and above and Java 1.7 and above, and they show mechanisms on how to use it. And they even mention, of course, the Gradle build dependency, so that if we were going to go into our existing Gradle app and simply paste this dependency string inside of it with whatever the latest version is, then Android Studio would go ahead and download it and make all of those classes available. I'm not going to use that at the moment. I have yet another alternative, but I did want to mention this as it is an extremely popular alternative for doing anything involving HTTP networks. The one that I want to talk about is a project from Spring known as Spring for Android. And here is the web page for that one, projects.spring.io, Spring-Android. Now, if you're familiar with the Spring framework, and virtually all Java developers are, you might be thinking that if you're talking about Spring for Android, are we talking about putting some sort of dependency injection framework on a handheld device? And this is actually not that. The Spring framework is probably one of the most common, most frequently used open source projects in the Java ecosystem. And it is used for dependency injection and managing beans and all that kind of stuff. But Spring for Android is actually much, much simpler than that. If I look at the documentation, and I'm going to look at the release version, this 1.0.1 release reference here, then they point out that the modules that are included are ones, well, there's two of them available. One is called the REST template, and the other is an authentication module. And that's pretty much it. There's a core that they both work with, but that's all that's there. This is not a dependency injection framework for mobile. Google Juice has one of those if you're looking for that. And there's some other alternatives as well. But right now, all I'm interested in is the REST template. Now, if you've ever worked with a Spring MVC application, and again, that's a very popular framework for building model view controller applications, you may be familiar with Spring's REST template in general. The REST template makes it very, very easy to access, to invoke get, post, put, or delete methods and have them turn the results or the arguments into whatever objects we want. Let's take a look as an example. The REST template methods here are listed in the documentation. And if I start with deletes, you can see the way these are designed. The delete method takes a URL to represent the location we're going to, and then object ... of URL variables. That collection is basically a set of values to plug into the URL wherever the URL has wildcards in it, these so-called URL templates. We'll plug values in, and this would execute a delete on the server using that URL and return nothing, as it turns out. Now, a GET request, and this is the one we're going to wind up using, looks like this. Get for object, again, takes a URL, and again at the end has object ... of variables to plug into the URL. And here's the cool part. Once it does the retrieval of the presumably JSON data, although it can be XML as well, but in my case it's going to be JSON data, you provide a class that will map to that JSON data. And then Get for object will invoke one of its own mappers to convert the JSON data into an instance of the class you provide. In other words, you don't need to parse the JSON data yourself. You don't need to dig into it and pull variables out and convert data types and then plug it into an object. Instead, you provide the class that maps automatically to the response, and it will populate that object and return an instance of it for you. So there's get for object. There's also a get for entity, which would return a response entity. That's the same thing as before, except it includes the headers in the response. So if you really needed to see the headers, you could also call that method and find those out. In my case, I don't really need that. Other methods available, head for headers. If all you cared about was the headers and not the body of the request, you could send a head request to a URL with some variables and get back an instance of HTTP headers. Options for allow allows you to go to a URL and find out the set of available HTTP methods at that location. Get, post, put, delete, head, options, whatever else, patch, whatever else they decided to support at that web service. Post for location is very interesting. Post for location says, give me the URL and my variables and an object to insert at the server side. That's the goal. Is now we're going to take an object and we're going to add it to the server side. Now, one convention that happens very frequently with RESTful web services is that when you insert an object on the server side provides to you a new URL for that object, a generated URL to say, okay, you just added a new widget, or you just added a new order or a new customer. Here is the URL associated with that new item. And it's normally returned as a location header in the HTTP response. Well, this post for location looks for that response header and automatically converts it to a URI and hands you back the URI. So if you did a post for location, the return type is the URI of the newly returned object. And of course, you get a 201 created and everything. Finally, there's also a put method, which is used for updates. You put in a URL and the variables and supply an object, and that's supposed to update that existing object and returns nothing. All of those methods are built right in. We don't see any of the actual networking or serializing or deserializing of the objects. All of that happens under the hood, making this much, much simpler. Now, how does it actually serialize and deserialize the objects? It uses what are called message converters. Now, there's an interface for message converters. I'm not interested in implementing that myself. I'm interested in looking at the message converters that come with Spring for Android, that are already built in. Again, if you've ever used Spring MVC, these message converters are the same ones that are used there when you convert something into a RESTful web service. So they always have available a byte array HTTP message converter or a string HTTP message converter or several of these others. The string one, for example, will say, look, whatever I got back, JSON data, what have you, convert it to a string and that's all I want to do, and I'll do my own post-processing on that. That's one option. Another option further down is the Jackson 2 or Jackson 1, but primarily Jackson 2 converter. The JSON Jackson Java library, how much alliteration do you want, is a library that automatically converts Java code into JSON objects and back again, as long as the attribute names in the Java classes match the properties of the JSON object. In addition to these, there's also one possibility, which is the one I'm going to use. Let me skip these. I'm going to use the JSON HTTP message converter. That's Google's JSON. It uses the Google JSON library for automatically mapping JSON to XML. Pardon me, JSON XML would be an interesting trick. At any rate, JSON to Java objects and back again. In order to use that, they show me what the dependency looks like, and once again, this is something I could add to my Gradle build file using the group ID and then a colon and then the artifact ID and then a colon and then the version number. And that's everything I need in order to have a background on how to work with the Spring for Android project. In my particular case, I don't need any of the authorization or authentication parts. I only need to access a publicly available web service and download data and convert it into an object. In the next segment, I'm actually going to do that. I'm going to show you the web service we're going to access, and then I'll show you the code that accesses it. And of course, that access will be inside of an asynchronous task. And then we'll see everything work together. So that'll come up in our next section.